Logarithmic functions and models. The base b logarithm of x is the power to which we need to raise b in order to get x. So log base b of x equals y means that b to the y is equal to x. We have a couple of standard abbreviations. If there's no base in our logarithm, typically it's base 10. If we use ln, that usually stands for base e log of x. Of course, logarithms have a number of properties, and all of these properties come from the properties for powers. So for example, base b log of x times y is base b log of x plus base b log of y. The log of x over y is the log of x minus the log of y. The log of x to the r is r times log of x. The base b log of b is 1, and the base b log of 1 is 0. The log of 1 over x is negative the log of x. And if we want to change from base b logs to base a logs, the base b log of x is equal to the base a log of x divided by the base a log of b. This last property is critical if you want to use your calculator. Your calculator probably only has base 10 logs and natural logs. So converting something like a base 2 log might be very, very important to you. Couple of additional laws. The identity law. The log base b of b to the x is equal to x, and b to the power of log base b of x is equal to x. So for example, base 2 log of 2 to the 7 is equal to 7. And 5 to the log base 5 of 8 is equal to 8. Going back to the change of base formulas, the base b log of a is equal to the natural log of a over the natural log of b, or the base 10 log of a over the base 10 log of b. So for example, the base 11 log of 9 is equal to the base 10 log of 9 divided by the base 10 log of 11, or about 0.916. The base 11 log of 9 can also be written as natural log 9 divided by natural log 11, or approximately 0.916. Natural logarithm functions either have the form f of x equals log base b of x plus c, or alternatively, a times the natural log of x plus c. So as an example, let's sketch the graph of f of x equals base 2 log of x. We start with a table of values and use some values we'll pick for f of x, and then we'll use those to find values of x. So we take base 2 log of x equals -3, -2, -1, 0, 1, 2, 3. So for example, if we take log base 2 of x is equal to 3, that means that x is equal to 2 to the 3, or 8. If we take log base 2 of x equals 2, that means 2 to the 2 is equal to x, or 4 is equal to x, and so on. Using this table of values, we can construct a graph of the base 2 log of x. Here's another example. A 10-year government bond yields 3.5% interest per year. At that interest rate, how long will it take $1,000 $1,000 investment to be worth $1,200 if the interest is compounded monthly. So first, let's take a look at what we've got. A is going to be $1,200. P is going to be $1,000. Our rate is 0.035, and our M is 12 compoundings per year. Using the compound interest formula, we get 1,200 is equal to 1,000 times 1 plus 0.0350 divided by 12 to the power of 5t, which we can simplify to say that 1,200 is about 1,000 times 1.002917 to the power of 12t. We say approximately here because 0.035 divided by 12 isn't exactly 0.002917. We can divide both sides by 1,000 here and get 1.2 on the left is equal to 1.002917. Take natural logs on both sides, and using the properties of logs, 1.002917 to the power of 12t, the log of that is going to be 12t times the log of 1.002917. Divide both sides by the log of 1.002917, and we now know what 12t is. And if we know what 12t is, then we certainly know what t is, in this case about 5.2 years.